Hi guys, today we're going to do the 2001 AP Physics B free response question. I had to restart the video because I messed up a little and all my work is here, so I'll go through it all. So it says, 4 charged particles are held fixed at the corners of a square at side S. All the charges have the same magnitude q, but 2 are positive and 2 are negative. In arrangement 1 shown above, charges of the same sign are at opposite corners. Express your answers to part A and B in terms of the given quantities and fundamental constants. Part A. For arrangement 1, determine the following. The electrostatic potential at the center of the square. So you're going to have to do first you have K sigma Q over R, and all distances are R away. So for 1, you have V equals K, parentheses, negative Q over R, plus negative Q over R, plus Q over R, plus Q over R. And you have V equals 0. 2, it wants the magnitude of the electric field at the center of the square. So you have E equals F over Q, and since it's at the center, E equals 0. Now, on to the next part. The bottom 2 charged particles are now switched to form arrangement 2 shown above, in which the positively charged particles are on the left and the negatively charged particles are on the right. B. For arrangement 2, determine the following. 1. The electrostatic potential at the center of the square. So for that, we're going to do the same thing as before. B1. So we're going to do V equals K negative Q over R plus negative Q over R plus Q over R plus Q over R, and you get V equals 0. And now the magnitude of the electric field at the center of the square. So what we did over here was R squared is equal to S squared over 2. We had E equals 4K, 4 charges, times KQ over R squared cosine theta. And our angle here is 45 degrees, as shown. So we have E equals 4K 2Q over S squared, because when you substitute that in for R squared, you have to bring the 2 to the top. And cosine of 45 is radical 2 over 2. And that gives you radical 2Q over pi epsilon S squared equals E. Now, the next part. In which of the 2 arrangements would more work be required to remove the particle at the upper right corner from its present position to a distance it would be arrangement 1, because the top right of arrangement 1, A1, is surrounded by 2 positive charges pushing further. Top right of arrangement 2 is surrounded by 1 positive and 1 negative. So not as far. That's why it's arrangement 1. Thanks, guys.